Last class we have discussed the thermistor, thermocouple, thermistor and RTD in industrial instrumentation. Now in this class we will discuss about the thermocouples. We are discussing one subject named as industrial instrumentation. So that right now we will discuss about the theory of operation of thermocouples. So generally we have discussed this topics in transducer sensors. So you can see this diagram. This is thermocouple. This is look like this is the thermocouples. This is the this is like one junction is hot junction. Hot junction. This is the cold junction. TC temperatures. Cold and cold junctions. This are two metals. Metal one and metal two are connected. Hot or cold junctions. This, because we are connecting the same metal, same metals between them, so there is no current or voltage will exist here. So simple thermocouple develop. The principle of a thermocouple is a temperature sensing devices that operate based on the Seebeck effect. This effect states that when two dissimilar matter are joined together at different junctions, the electromotive force or voltage is generated which is proportional to the temperature between the junctions. Means here the electromagnetic force or voltage is directly proportional to the temperatures. Then V is equal to S dot delta T S is a sensitivity. That's S is that's proportional B proportional to delta T, where V0 is where remove the proportional this S will come. That's S is called thermocouple sensitivity, which depend on the materials. Hot junction a point where two metal are joined and exposed to the temperature to be measured. The hot junction a junction where which point temperature to be measured. Cool junction or others name is the reference junctions in other end of the thermocouple that keep a known reference temperature, often 8 mid or control temperatures. Output voltage. The generated voltage is measured and correlated with temperatures using standard thermocouples or time equation. The relationship between the temperatures and voltage is non-linear and varies depending on the type of material used in thermocouples. An idea of thermocouple is based on the three principal effect discovered by Seebeck, Filter, and Thomson. This Seebeck effect occurs when two similar matter are joined together. It create electromagnetic force. The this this electromagnetic force vary depend on the type of metal or material used and temperature different between the two junctions. So this Seebeck effect principle behind that operation of thermocouples were designed and were generated voltage used to measure the temperature differences. We see this is the voltage V directly proportional to delta temperatures that is this is a Seebeck effect. Filter effect and electromagnetic force EMF generated in a circuit when two dissimilar matter are joined together to form a junction. Due to temperature difference between these two junctions, the varying the temperature caused the voltage developed across the as temperature is varies, the cause the voltage across the junctions that can be measured using different temperature. Next, the Thomson effect that occur when Heat is observed or released along the length of conductor at different temperatures. At the end, this effect released to the flow of electric current through the conductor and the temperature gradient. Here, mainly because of temperature gradient, essentially Thomson effect describes the temperature of conductor changes its response of electric current and its distribution along the road. Means this two road is there. In this road, temperature exists different one temperature here temperature because of current is flow from suppose that here to here. So because of flowing the current, temperature gradient exists here because of because of temperature caused to voltage develop because the voltage is developed because of change in temperatures. Here, this is the voltage, and here EMF varies depend on the metals that used at temperature different. EMF generated voltage is vary the first depend on the metals, and so this was the thermo EMF type of different type of thermocouples. We have also discussed the previous thermo in design level is JKT and with different temperature sensing. But first is a nickel chromium, and like the most common those are most common good accuracy oxidation. Most common element is nickel chromium. K type, this is generally most common good accuracy oxidation environment. Generally, this is the K type material. Nickel or chromium generally most used in industries. The most common because of good accuracy, cost is also less. J type J type iron constants we can use. Temperature minus 40 to 750 degrees Celsius. This is the suitable for reducing environment, not for oxidizing. The range of K type is minus 200 to 1200. T type, this is the range of minus 250 to 400. The high accuracy, good for cryogenic. Very high accuracy. This is the for very high accuracy. E type chromal constant, high output, but range in minus 270 to 870. High output voltage. This is then generally then this three are the importance you should know: K type, J type, T type, and E type. Next is you should know R type. Platinum road 30%, temperature 0 to 60, the high accuracy, extensive in used lab and industries. Generally, these are used for temperature measurement. B type generally rhodium 30% and 6% others. So that's the best for extremely high temperature. Extremely high temperature B type is used. This is a thermocouple. Next, the next sensor we will discuss about the diode type temperature sensors. So in the diode type temperature sensors operate based on the temperature depend on the voltage characteristics of semiconductor diode or transistors. These type of these sensor leverage a predictable changes for voltage drop BP. So these sensors are leverage of the predictable change for voltage drop. The working the semiconductor for semiconductor behavior VF is given by VT into Ln. This is the Ln log IF forward current divided by a IS saturation current. This behavior follow equation this where Vt equal to Kt upon Q. 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 IF forward, IS is the saturation current. The temperature sensitivity when a constant current is passed through a diode, a forward voltage drop approximately minus 2 2 volt. This change in voltage accurately measured using the temperature sensor. Type of diode sensors. Type of diode is a discrete diode. Discrete diode look like this. This this is number of 1N418 diode. This is the 418. This is the this part upper part is a cathode, lower part is a anode. This is the symbol look like this. This is the originally diode look like this. Real diode. This is a symbolic representation. This is the animated representation. See the type of diode temperature sensors. This one can be use the standard silicon diode like 141, less accurate compared to integrated solutions, but useful applications. Next is a transistor sensors. Second is a type of temperature diode sensors, transistor sensor. For transistor sensor, we can use the transistor name is a 2N. The transistor name is a 2N3904. This is the very useful transistor. It's also good for high frequency applications. BJT, the commonly used BJT transistor, base emitter junction acting as a base emitter junction. It offer better stability. It also work as suppose that this is the transistors. This like if base emitter junction. If we sort this transistor look like this. So here this work as a base emitter BE junction. This work as a diode. So this is also can use for temperature measurement. How they are using approximated the forward its forward voltage drop, that's VF. So base emitter voltage changes according to VT into Ln divided by in this Is via Fs. If its temperature changes, then its voltage VF forward voltage of across the diode changes. Based on this, we are measuring how if temperature changes according to Vt barabar. Vt will change how? So Vt is equal to Kt upon Q, because so temperature changes, V is directly proportional to this. Vt is directly proportional to temperatures. Vt is directly proportional to temperature. Voltage forwards in ice saturation. Temperature sensitivity. When a constant current is flow through a diode in forward bias, approximately change in voltage can be accurately measured to determine temperatures. So constant current and constant any constant current passes through it. So if forward voltage changes per milli, then any one is forward voltage changes per degree Celsius is -2 millivolt. Temperature type of diodes. This is a concept that can be used. These are integrated sets of ICs use the precision fabrication diode inside ICs. Generally LM35 IC, general LM35. The LM35 is 3-pin IC. First is a VCC. This is the power supply which can be used 32 volt or 4 volt. This is the output, analog output. This is the output. This is the must be analog. This is output. This is the ground. This is the LM35 IC that used to measurement the temperatures. Selections criteria for consideration. Temperature ranges. Choose a typical or suitable operating point. Accuracy platinum base thermocouple RSB, very high accuracy is there. Temperature ranges. Choose a suitable for the different temperature ranges. Based on that, we can choose temperature ranges. Accuracy platinum based thermometer RSB for high accuracy. Platinum based RSB thermocouple platinum rhodium. This is very accuracy. This is very high. Environment conditions like for oxidation reduction, corrosion atmosphere, we can use the cost and life lifespan. K type are cost effective. That's why generally K type used. Most industries K type are used because this is the most cost effective and durable. While B is expensive but work extreme temperature. B For maximum temperature we need an, but it can be measured up to 1800 degrees Celsius, but it is the costly. So in this class we have discussed the different types of sensors, thermocouples,